Good afternoon, folks. I'm inclined to say fasten your seatbelt, sit back, relax, and enjoy this drive before we break for lunch. So, on that note, let's begin. Almost a century ago, Henry Ford was quoted saying, "If I asked people what they wanted, they would have probably told, I want faster horses." Let's be glad that that really didn't happen, because if that was the case, the outer ring road and the car parking would look much different today. And many years ago, I don't know if somebody really asked this question, but I suppose if somebody asked what I would need in a communication device, maybe the response would be, okay, I have a telephone. I need a device that can help me talk or send messages on the go. Today, cars are fondly called as smartphone on wheels. And therefore, if auto manufacturers today ask the same question, what would you need? The expectations are going to be extremely multidimensional. And if there is one common denominator that can manage this technology evolution in the world of mobility and can meet the expectations of the user, I guess it has to be undoubtedly software. Today, it is not just the horsepower that drives the car, it is the software that drives the car. Software is playing many roles in cars today. It's taking care of your wonderful smart cockpit. It's able to bring in efficiencies in your car. It's able to manage the drivability, the ease of driving, navigation, communication, so on and so forth. In fact, in a recent industry automotive exhibition held in Munich, cars are not just called the smartphone on wheels, they are now being called a smart habitat on wheels. Which means the world of mobility, and let me be in particular, the world of automotive software is undergoing a tremendous change. And such a change is a fantastic place to be for all of us, right? As technologists, it's a fantastic place to be. And that's where our journey in Thoughtworks in the world of SDV began. And we began to hypothesize a lot of software themes. I know some of you might see the word bet with a negative connotation, but we have used it here with the connotation that signifies certainty and belief. Because we strongly believe that the themes that we have picked up can really create an extraordinary impact in the world of software-defined vehicle. Now, before we go any further, let's clarify a few jargons, because if you have been reading a lot of industry reports, it's pretty common to come across these terms. CASE and ACES mean the same. These are mega trends that come talking about connected cars, autonomous cars, because they no longer are science fiction. The shared mobility, which is able to bring in new business models, and not last but not the least, the world of electrification and its associated infrastructure ecosystem. Quite recently, we have also seen the term cases. The S at the end means a very important aspect, which is security. But of late, there has been one other jargon which is taking pole position, and that's SDV, or software defined vehicle. Now you might ask, hey Sriram, what is SDV and why SDV? Well, I'd keep my answer very simple. The value differentiator in a car today is very clearly determined by the software that goes into it. The features, the functions that a user can experience is driven by software. And hence, I guess it's pretty straightforward to call it software-defined vehicle. Now, when we go through an evolution or when we go through a change, it's always complex, because there's a lot of legacy attached to our past. And the world of automotive software is not excluded out of it. So, of course, the legacy brought in a lot of challenges, but the world of software-defined vehicle is bringing in a lot of opportunities. The SDV stack is giving you at least opportunities in terms of areas where the hardware and the software is decoupled, which means you're able to bring in modern software engineering practices into the world of mobility. It's no longer a case where you need to wait for years to get features and functions on your car. Today's user wants it in days and sometimes in hours. And that's possible in a software defined vehicle. Last but not the least, the ability to bring in new technologies and improve the developer experience is also a fundamental advantage in the SDV ecosystem. So, oh yes, there are challenges because it's never simple to manage a change. And that's where our vision came into place, where we said we wanted to crack the software complexity in software defined vehicle. And we embarked on this journey where we began experimenting and delivering a lot of software themes. Today's morning top 10 tech trends, in fact, featured many of these trends, which gave us a boost that we are in the right direction. Whether it's product of data, whether it's bringing in zero trust in terms of cybersecurity and the DevOps principles, bringing in new technologies like Rust in automotive. Barney asked, is Wasm known to us? And many of us didn't raise our hands and was looking for a uh, for an for a for a space where Wasm can be that game changer. Is it going to be automotive? Let's figure out. But very clearly, as was quoted in the IEEE document in June 2021, software is indeed eating the car, and we are very happy here to showcase some of the themes. So let's shift gears and see what we have done in this space. Over to you, Sreelakshmi.
Thank you, Sriram, for that power-packed introduction. I hope we all are on the same page now, that we agree that this is indeed the era of software-defined vehicles. So I am here to walk you through some of the technological trends that our team has been exploring. Let's start. So when we think about building software for cars, the languages that would come to your mind would be C or C++. These languages are kind of the best friends or trustworthy allies or go-to programming languages for systems with limited resources. On that note, let me present to you our first topic for today, which is Rust in automotive. Yeah, the languages like C and C++ are widely used. They are reliable most of the times, but there is a catch. If we do not handle use cases related to memory safety or concurrency very carefully, there is a chance that the system might run into issues. I know we write unit tests, or in automotive, we have MISTRA guidelines to do static code analysis. I know we do all of that. But what if I say, just by using the right programming language, you will be able to identify these kind of issues at a very early stage of development, even before you run your unit test or even before you run your MISTRA guidelines check. Yes, that is what can be achieved with Rust. I have personally felt like Rust is kind of a superhero among the programming languages that is specifically designed to address these kind of use cases. Not only that, Rust also offers comparable performance as that of C and C++. That is why we believe that Rust will definitely find its way in the space of software-defined vehicles. So Rust comes with a sophisticated build system called Cargo, which allows the developers to follow software development practices like test-driven development. There is dependency management handled through a system of crates. We even have tools for formatting and even documentation. So it's like a wholesome package that comes with Rust. So this mature ecosystem of tools helps in standardization of large projects. And of course, it enhances developer productivity. So we have been exploring this amazing potential of Rust in our team. So we have deployed Rust code on different targets. The concepts of interoperability or memory safety has been evaluated. Believe me, interoperability between Rust and C or Rust and C++ is not that straightforward. So we can use libraries like CXX wrapper or CBindgen to generate that glue code so that Rust and C code or Rust and C++ code can work together. So recently, we did our experiments with a well-known open-source autonomous driving software stack called AutoWare. So AutoWare is based on ROS framework, and the code base is written in C++. So what we did there was we implemented the Kalman filter algorithm, which is used in the localization stack of autonomous vehicles using Rust. And then we integrated this Rust code with C++. This way, we were able to experience how Rust makes the code more safer. Not only that, we were able to experience how challenging it is to integrate Rust code with an existing C++ code base. Not only ROS, you would have already heard of AutoSAR if you are an automotive enthusiast. So AutoSAR is a global partnership among automotive companies. So Thoughtworks is a partner, or Thoughtworks is collaborating with AutoSAR. There is a Rust safety group in AutoSAR. The aim of the Rust safety group is to bring in Rust code on top of uh, adaptive AutoSAR, which is a widely used middleware in ADAS applications. Not only that, Thoughtworks is collaborating with a lot of other external communities to make sure that Rust will definitely march into this space as early as possible. There are internal community activities also taking place. So if you are keen on learning any new programming language, I would definitely recommend you Rust. It's very interesting. You would love it. So we know that Rust is a suitable choice for automotive software, but there is a but there. Because the existing software components are already implemented using C or C++. So if you want to introduce a new software component, even though we know that there is a right choice for that software component, it might be difficult for us to make that choice because of the interoperability hurdles that we have to overcome. Not only that, the industry is faced with a lot of other challenges. For example, for every new hardware, even the top level software has to be rebuilt again and again. That's because there is no decoupling between hardware and the topmost layer of software. So that decoupling is not achieved yet. And also in this era of software-defined vehicles, it's very important to give OT updates regularly, right? So we were thinking, is there any way to bring in language independence to automotive software? Or is there any way we can bring in platform portability features? That's how we came across our second topic for today, which is WebAssembly for embedded systems. WebAssembly or WASM is not a new term at all. WebAssembly is there. It has been there for some time now. It's from the web world itself. But soon after it was released, it was realized that WebAssembly is a binary format or an instruction set. It can be made to work irrespective of its surroundings. And also, WebAssembly was mainly released to achieve things like high speed and runtime efficiency. Doesn't that sound exactly similar to what we need in systems with limited resources or safety critical functions? We also thought so. And that's how we began trying out or experimenting with WebAssembly on embedded systems. So with WebAssembly or WASM, we can create new software components and they can be deployed onto different targets. So it makes the process of updation easier. Not only this target device, it varies from a web browser to a resource-constrained embedded system. And we can write code in any programming language we want because in the end, it is going to be compiled into a WASM binary. So with WebAssembly, we created an automotive software functionality and was deployed into 3 different targets. First one was a microprocessor, then to a microcontroller, and to a web browser. So we had a single pipeline to generate this WASM binary, which was deployed to 3 different targets. So we were able to experience the platform portability that comes with WebAssembly. Not only that, see, if you have 2 apps running on the same target, you can make code changes for application 1, compile it into WASM binary, and deploy it in your target device without even affecting the execution of application 2. Because with WebAssembly, we get sandboxed execution environments. That brings in the concept of containerization into automotive. So the concept of containerization in automotive has always been challenging to implement. But with Wasm, we get lightweight containers. And containerization is also now possible. So enough of all of the safety critical features. Now let's shift our attention to some mixed safety critical features. So we have been iterating multiple times that it is the users who are really driving the innovation. And we should give utmost priority to the user experience. So how do the users interact with their vehicle? It's through human-machine interfaces. These days, users even has begun to evaluate their overall experience with the vehicle in terms of what they get out of their human-machine interfaces. That's a little bit of challenging position to be in, right? So HMI application has evolved to be more complex and challenging these days. Even you could also think of, right, in the past, we just had an instrument cluster and an infotainment unit, and that was it. Now that's not the case. HMIs have evolved much beyond displays. We have a lot of immersive features coming into the cars. When it comes to the displays, we even have the whole digital cockpits. Then we have rear seat infotainment systems. We even have displays dedicated for gaming or streaming services. So there is a need to bring in consistent performance across all these devices. And no matter what, the software has to go inside a vehicle. So quality of the software can never be compromised because safety is of utmost priority. In addition to this, we don't have years to release new features. We have to be as quick as possible. And when it's connected to the users, we have to be more quick in releasing new features. So considering all this, we were thinking, if we can bring in more people to the HMA application development by using tools that has a larger community appeal, then that would ease the situation a bit. That's how we began evaluating modern development tools, and Flutter is a tool that caught our attention. You might have already heard of Flutter. Flutter is an open source tool which is provided by Google, and Flutter is already known to be fast and productive. It comes with a wide variety of testing, debugging, and development features. And of course, Flutter supports multiple platforms. We can build mobile applications with it, web applications with it. Now it works on embedded systems too. You can have your own customized Yocto builds, or you can make it work on top of Android environment. That's also possible. And Flutter offers flexibility. So with Flutter, the developers can create customized adaptive designs. So with Flutter, we created an application and deployed it to an embedded target. The target device was a Raspberry Pi, and the application was an instrument cluster application. The instrument cluster receives data like current speed, current gear, turn indicators, and all from the simulated environment, and it updates on the display. Later, we integrated this application onto a real vehicle, but that's a little bit of a surprise that's going to come in the end. Just wait for it. Let's come back. We were also able to experience how Flutter enhances the developer productivity. Like we were able to test features like hot reload and hot restart on embedded targets itself. Now the developers can instantly view their code changes on target devices. So just say goodbye to taking long breaks after making a minor change and putting it for build. Those days are over. Now modern development tools are going to take over. Not only that, we created an embedded pipeline for this application. So it consists of different stages like linting, unit testing, widget testing, integration testing, followed by build, and it was later deployed onto the target device. So Flutter also comes as a wholesome package, just like Rust. So it's very easy for the developers to set their development environment. Yeah, so with this embedded pipeline, we can make sure that for every new commit, all these tests are performed automatically. And this way, we can also capture bugs at a very early stage of development. On that note, let's go to the next topic, which is vehicle DevOps. So before going into the definition of vehicle DevOps, let me tell you a story. So this story happened decades ago. That is when the horsepower was still ruling the industry. Software has not come to the picture yet. So decades ago, it was the automotive giants who revolutionized production by minimizing waste, maximizing productivity, optimizing the processes by introducing a new concept called lean manufacturing technique. So later, this technique was adopted by other industries as well. Now let's come to the present. The irony is that the same automotive industry is now facing issues like identification of bugs at a very last stage of development, very late response to change requests, slower feedback cycles, and long development times in its software processes. So, this is not something that has happened uniquely to the automotive industry. The traditional software industry has also faced these kind of issues. And that's how the DevOps movement emerged a decade ago. So the principles of DevOps were basically developed to address all the challenges that they were facing in traditional software industry. And DevOps principles were heavily overdrawn from the principles of lean manufacturing technique. Interesting, isn't it? So we are not saying that we just have to cut and paste DevOps methods from the traditional industry to automotive industry. That's not what we are suggesting. But still, it's a very great place to start with. So understanding the unique challenges of automotive software development, we coined this practice of vehicle DevOps. So now let's look at the definition. It's a set of practices and principles that are designed to accelerate software delivery in the automotive industry. So there are three main pillars for vehicle DevOps. The first one is the technical aspect, like how we should embrace techniques like continuous integration or continuous deployment as part of our development, or how important it is to have automated testing in place, how important it is to have trunk-based development. Let's go to the next pillar, which is the people aspect. So how important it is to have smaller autonomous teams with diverse skill set, rather than just having developers with expertise in one domain alone. Like, in addition to technical depth, we need technical breadth as well. And not only that, it covers things like how important it is to share feedbacks, or how important it is to use the right tools at the right place. And the third pillar of vehicle DevOps is the organizational competitiveness. The change has to come at an organizational level. It is the organization that has to adapt to the evolving requirements around it. So Thoughtworks has always been an amazing partner for its clients and has helped the clients in achieving competitive software delivery by implementing the principles of vehicle DevOps. So we believe that just like lean manufacturing revolutionized manufacturing in the past, vehicle DevOps is going to revolutionize the software factory. All right, next topic. It's time for another story. Imagine you are in your favorite vehicle. You are heading to somewhere because it's the journey that matters. Your vehicle seems to understand you very well. Like, it knows what is the right temperature setting for you, or it knows what media you would like to listen to, or what is the correct seat adjustment that you would prefer. Now let's take it one step forward. Imagine you are in your autonomous car. Now your vehicle seems to know uh, how to take turns safely, or how to guard you on your journeys in highways, or how to navigate tiresome traffic. Doesn't this sound magical? Well, it's not magic. In SDVs, an array of data come together to create this personalized, safe, and magical experiences for you. So there is a lot of data involved in SDVs, like data from external environment, like sensor data, traffic data, connectivity related data, data related to streaming services. Then we have status data, like door status or fuel level. Then we have data related to user preferences. What are the features that the users would prefer to use? So the 5 big V's of data are applicable in SDVs also. There is a huge volume of data, like around 20 terabytes per hour. or there's a huge velocity of data, again in gigabytes per second. And we have a variety of data, and the veracity of data has to be verified, and we have to find some value out of this data. So these are the three main core themes that we have been exploring in our team. And the first, how to convert this data into a product. So as I mentioned, there is a lot of data involved. So we must implement some strategy to collect, transfer, and give access to this data. So we believe that the principles of data mesh are very well applicable to software-defined vehicles also. So as the first step towards it, we created a self-serve data platform that acts as an entry point for the data from the vehicle to the cloud. The next one is CD4RL. As you have guessed, it's similar to CD4ML. It's like continuous deployment for reinforcement learning. So the idea is to bring in the techniques of continuous deployment into MLOps training processes. So we have an end-to-end pipeline created for this. The moment a new change is pushed to the repo, training begins and followed by testing, and it was later deployed into the target device. The target in our case was a deep racer. And CD4RL also enhances developer productivity. They can now focus on creating and building new models rather than bogging down on the processes that comes afterwards. The next topic was liquid neural networks. Here we are trying to analyze how we can bring in the advantages that are possessed by liquid neural networks into the space of SDVs. So liquid neural networks are continuous time-based neural networks, and they are said to be more adaptive. Like they can be trained in one environment and can be tested in another environment and still it works. And they are said to be more interpretable and scalable. So these are the requirements that we would need in software-defined vehicles as well. So we are currently exploring how we can bring in these concepts onto edge devices inside vehicle. Yeah, that's all from my end. I think, Sriram, it's time for us to connect the dots for them. Let's reveal our little surprise.
Thank you, Sreelakshmi. At Thoughtworks, we strongly believe that it's very important to see value in the work that we start, right? And I think it's not just at Thoughtworks. As technologists, it's very important that we see that minimal viable product in action very fast and get that feedback, right? And it is with that intent, you already see a toy outside. Do look at it, feel the experience there. But we also have a vehicle demonstrator in our Coimbatore office where we have put all those topics that we just described into action, right? Because it's very important to give code a life, right? And that's what we have done with this vehicle demonstrator. It's been very exciting for us to work on this and figure out how software in a vehicle really works. Having said that, it's very clear that mobility, and many automotive CEOs have echoed this, it's not just moving from A to B. It is the experience when you move from A to B that matters. I think there was an age-old saying which said, it's not the destination, but it's a journey. And I think it's perfectly placed for the world of mobility today. Having said that, it's also very important that all of us come together, right? Many organizations themselves are coming together. We see a lot of consortia playing a very active role, consortia like AutoSAR, SOFI, Covisa, AVCC, and many more, who are driving collaboration, not just in standards, but also in execution. Because very clearly SDV is about an ecosystem play. So we invite you also to be part of these communities and see what we all can do together to make the world of mobility much safer, much better, much efficient. Having said that, it's just starting. So very clearly there's a lot that we need to learn. There's a lot that we need to experiment. Very clearly we need to adapt to the changing trends. But last but not the least, deliver what user wants from the world of mobility. And we are absolutely thrilled and excited to lead in the SDV world. Thank you for your attention. Thank you.